On February 18th, 2021, a one-ton robot screaming through the Martian atmosphere at 12,000 miles per hour had exactly 7 minutes to slow down, or it would crater into the surface and end a $2.7 billion mission before it even began. No human could touch the controls. No signal from Earth could reach it in time. The round-trip communication delay between Earth and Mars that day was 11.5 minutes. By the time mission controllers at JPL even knew the spacecraft had hit the atmosphere, the whole thing, success or failure, would already be over. That was the moment Perseverance was born. The entry, descent, and landing sequence that night was the most sophisticated automated landing ever attempted on another planet. The spacecraft deployed a parachute just under a mile above the surface, then fired retrorocket thrusters to hover, then lowered the rover on nylon cables from a sky crane, a flying robot crane on another world, before the whole descent stage flew itself away and crashed at a safe distance. Engineers called it the 7 minutes of terror. 5 years later, that rover is still alive on Mars, still driving, still making discoveries that are rewriting what we know about the Red Planet. And what it has found is more interesting than anyone expected. NASA chose Jezero Crater as the landing site after years of debate, and it was a deliberate bet. Jezero is roughly 28 miles across, and scientists believed it was once a lake. A deep, ancient lake that existed 3.5 billion years ago, fed by a river that carved a visible delta into the crater wall. A delta means sediment. Sediment traps things, minerals, chemicals, and potentially preserved evidence of ancient microbial life. If Mars ever hosted biology, Jezero is one of the best places on the planet to look. The rover landed within 1.5 miles of its target, a precision touchdown in a boulder-strewn terrain that had made engineers sweat for years. Within days, the first images came back. Rust-red ground, flat and ancient, with the crater rim visible in the distance. Mars looked exactly like a place that used to be something else entirely. Perseverance carried 6 science instruments, 23 cameras, 2 microphones, making it the first mission to record actual sound on Mars, and a collection of tubes designed to gather and seal rock samples that no human hand has ever touched. It also carried a stowaway, a 4-pound helicopter strapped to its belly. But before we get to the helicopter, let's talk about what the rover found on the ground. The first year was largely a shakedown. Perseverance tested its instruments, checked its systems, and explored the ancient lakebed floor of Jezero. The geology was already surprising. Ground-penetrating radar beneath the surface revealed clear layering, ancient sediment deposits stacked on top of each other, a record of water activity written in rock. The crater floor had been reshaped multiple times by volcanic activity and water. This wasn't a simple, quiet lakebed. This was a dynamic, complex place that had been geologically active for millions of years. Then came the rock that changed everything about how scientists thought about this mission. In the river delta, the fan-shaped wedge of sediment where an ancient river once emptied into the lake, the rover found a mudstone called Wildcat Ridge. The rock formed roughly 3.5 billion years ago as mud and fine sand settled into a saltwater lake that was slowly evaporating. When scientists analyzed it with the rover's Sherlock instrument, they found organic molecules embedded in the rock. Organic molecules, the building blocks associated with life. That does not mean life. It is critical to say that clearly, organics can form through chemistry that has nothing to do with biology. But the context matters enormously. These molecules were found in a mudstone, formed in standing water, in a lake that once had the temperature, the chemistry, and the time to potentially support microbial life. The sample from Wildcat Ridge became one of the most scientifically valuable things Perseverance has ever drilled. The Delta campaign also turned up carbonates and silica, 2 minerals that are remarkable preservers of biological material. On Earth, silica-rich rocks contain fossils that are hundreds of millions of years old. The rover found them together in rocks from an environment that was once wet and chemically active. Scientists started using a word they rarely use in planetary science: tantalizing. By Sol 1000, the rover's 1000th Martian day on the surface reached in December 2023. Perseverance had collected 23 rock and sediment samples, sealed in titanium tubes and cached on the surface and inside the rover itself, waiting for a future mission to retrieve them. Each sample is a time capsule. Each one could answer questions we have been asking about Mars for decades. But the sample story has a twist, and we will get to it. First, the helicopter. When Ingenuity lifted off from the floor of Jezero Crater on April 19, 2021, it became the first powered, controlled aircraft to fly on another planet. Let that sink in for a moment. The Wright brothers' first flight at Kitty Hawk lasted 12 seconds and covered 120 feet. Ingenuity's first flight lasted 39 seconds and climbed to 10 feet. NASA actually carried a small piece of fabric from the original Wright flyer on board as a tribute. The Martian atmosphere is only about 1% as dense as Earth's. Flying there is like trying to fly a helicopter at 100,000 feet above Earth. To generate lift in air that thin, Ingenuity's rotors had to spin at 2,400 revolutions per minute, roughly 5 times faster than a standard helicopter on Earth. Nobody was certain it would work until it did. The original plan called for 5 test flights over 30 days. Then the mission ended, and Ingenuity was supposed to park somewhere and let Perseverance drive away. That is not what happened. Ingenuity kept flying. It became a scout, flying ahead of the rover, photographing the terrain, identifying obstacles, and helping mission planners choose the safest and most efficient routes. What was supposed to be a technology demonstration became an operational tool. Flight after flight, month after month, year after year, the little helicopter kept going. It flew 72 times. It covered more than 11 miles of Martian terrain. It flew in dust storms. It survived the brutal Martian winter, where overnight temperatures dropped to minus 130 degrees Fahrenheit. It operated from 48 different airfields across the crater floor. It dealt with a failing navigation sensor and still managed to land safely. It was, by any measure, one of the most successful technology demonstrations in the history of space exploration. Then, on January 18, 2024, Ingenuity took off for the 72nd time. About 20 seconds into the flight, its navigation system lost track of the ground. There were not enough surface features below it to reference. And when it touched down, it came in with too much horizontal velocity. The impact loads exceeded what the rotor blades were designed to handle. All 4 blades snapped off. The helicopter that was only supposed to fly 5 times had just flown its last. NASA officially ended the Ingenuity mission on January 25, 2024. It sat alone on the surface, photographing its own shadow, with one broken blade visible in the frame. The team at JPL called the image poignant. That's the right word. Ingenuity proved that aerial exploration of Mars is possible. Every future Mars helicopter, and there will be more, stands on what that 4-pound machine accomplished. Now back to those rock samples, because this is where the story gets complicated. Perseverance was never meant to bring its samples home alone. The plan, called Mars Sample Return, was always a 2-mission architecture. A separate lander would fly to Mars, deploy a small rocket, launch the sample container into Martian orbit, where another spacecraft would catch it and fly the whole package back to Earth. Scientists have been dreaming about this since the 1970s. Get actual Martian rock, rock from a lake, rock with potential biosignatures, into Earth labs, where the analytical tools are 1,000,000 times more powerful than anything that can fit on a rover. The plan was to return samples by the early 2030s. Then the cost estimates arrived. In 2024, NASA's independent review board revealed that Mars sample return had ballooned to somewhere between $8 billion and $11 billion, far beyond what Congress or the White House was prepared to fund. The original estimate had been around $4 billion. NASA canceled the existing mission design and went back to the drawing board, soliciting new proposals for cheaper, faster architectures that could potentially return samples by 2035, or possibly as late as 2039. Then, in 2025, the situation darkened further. The Trump administration's proposed NASA budget called the program grossly over budget and effectively ended funding for it, suggesting a pivot to lower-cost, competitively selected Mars science missions instead. What that means in practice is stark. Sitting on the surface of Mars right now, in titanium tubes sealed by a machine on another planet, are the most carefully selected and potentially life-bearing rock samples ever collected from another world. And right now, there is no funded plan to bring them home. Perseverance collected them anyway. It keeps collecting them. As of mid-2025, 33 of its 43 sample tubes had been filled. Because what else do? You keep going. The science does not stop because the politics got difficult. And what the rover found next was the biggest surprise of the mission. In July 2024, Perseverance was exploring a feature called Bright Angel, a set of ancient rocky outcrops along the edge of Neretva Vallis, the ancient river valley that fed water into Jezero crater billions of years ago. The channel is about a quarter-mile wide, carved by water that once ran fast and deep through this landscape. The rover drove into the edge of that channel and found a rock unlike anything it had seen before. The rock was named Chiava Falls. It was a pale, light-colored slab crosscut with orange and white veins, the kind of mineral pattern that forms when water seeps through cracks in rock and deposits new chemistry as it moves. But it was the small details that stopped scientists cold. Tiny spots, described as leopard spots, dotted the rock face. Each spot had a dark halo around it, enriched in iron and phosphate minerals called vivianite and greigite. On Earth, that specific pattern, organic matter surrounded by iron-bearing minerals in a fine-grained sedimentary rock, is one of the chemical signatures that microbial life leaves behind. When microbes metabolize iron, they leave halos. When organic chemistry happens in wet, fine-grained sediment, it leaves exactly this kind of pattern. NASA announced in early 2025 that Perseverance had detected a potential biosignature the previous year. The word potential carries enormous scientific weight. It means we cannot rule this out. It means the chemistry is consistent with life, but it is also consistent with certain non-biological processes. It means this is why we need to get these samples into Earth labs. A paper published in Nature in early 2025 described the find in detail. Scientists called the evidence compelling but not conclusive. The only way to know for certain is to run the kinds of isotopic and molecular analyses that require instruments the size of a building. Instruments that exist on Earth, not on Mars. The samples are there. The question of whether there is life in them, or was life, may already be answered. We just cannot read the answer yet. Through all of this, the rover itself keeps running. Mars is not a friendly place to operate machinery. The average temperature at Jezero crater is around -80 degrees Fahrenheit, with overnight lows plunging to -130 degrees Fahrenheit in winter. The Martian atmosphere is 96% carbon dioxide, and so thin that a human standing on the surface without a spacesuit would be dead in seconds. Not from cold or radiation first, but from the pressure drop. Dust storms can go global, blanketing the entire planet for months. That is what killed Opportunity rover in 2018. The dust blocked its solar panels, and it never recovered. Perseverance does not have that problem. It runs on a radioisotope thermoelectric generator, essentially a nuclear battery that converts heat from decaying plutonium into electricity. It does not need sunlight. It does not stop for dust. It operates through winter. Engineers at JPL completed a thorough assessment of every major system on the rover in 2025 and concluded it can keep operating until at least 2031, a decade from landing. As of April 2026, Perseverance has driven nearly 25 miles across Jezero crater. It is heading toward a region nicknamed Lac de Charmes along the crater rim, looking for new rock targets. Its wheels, its instruments, its cameras, all functional. It recently set a record single-day drive of 1,350 feet. For a robot on another planet, it is practically sprinting. 5 years in, 72 helicopter flights, 33 sealed sample tubes, oxygen made from Martian air, a potential biosignature in a rock that formed when Earth's continents were still taking shape. Here is the question that should keep you up at night. What happens to those samples if no one goes to get them? The tubes are sealed. The rock inside is preserved. Perseverance cached 10 of them in a depot on the surface of Mars specifically as a backup, so that even if the rover fails, a future mission could still retrieve them without the rover's help. Scientists spent decades arguing about whether Mars ever had life. Perseverance may have already collected the answer. It is sitting in a titanium tube on a red planet 140 million miles away, waiting. That is either the most important thing humanity has ever done or the most frustrating. Maybe both. So tell me, do you think those samples ever make it back to Earth? Drop your answer in the comments and tell me whether you think Chajava Falls is the real thing. If this blew your mind even a little, hit the like button and share it with someone who needs to start paying attention to what's happening on Mars right now. And make sure you're subscribed, because next week we're covering the mission that could actually follow Perseverance to the surface and the technology being built right now to bring those samples home. The story isn't over. It's just getting started.